Welcome to the Architect of Sleep channel. Today, we're taking a quiet journey across our solar system, from the blazing heart of our star to the frozen edges of its distant realm. We'll follow the sunlight as it dances across Saturn's rings, listen to the silent storm swirling on Jupiter, and brush our thoughts against the ancient rocks of Mars. This is not a tour guided by charts or diagrams, but a gentle exploration of sensations and wonders hidden within the sun's gravitational embrace. We'll watch chaos and order intertwine into a single majestic dance of planets, moons, and drifting asteroids, an eternal, wordless ballet unfolding above our heads every night. If you enjoy these peaceful journeys, feel free to like the video, subscribe, or leave a quiet thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy and your mind soften. Let's begin. At the center of our system burns a star, but this is not fire as we know it. It is a colossal nuclear engine, endlessly transforming matter. Deep in its core, under a pressure 340 billion times greater than that on Earth's surface, hydrogen atoms fuse into helium. This process, nuclear fusion, releases photons of energy that take hundreds of thousands of years to fight their way through the sun's dense plasma, only to travel the final distance to Earth in just 8 minutes as light and warmth. It's not burning that consumes oxygen, it's the pure conversion of matter into energy, a dance of the universe's fundamental forces that creates light itself. Our sun is not a bonfire, but a timeless song of matter becoming radiance, a song that shapes everything within its gravitational hold. And that hold extends far. The sun is so massive that it makes up 99.86% of the entire solar system's mass. All the planets, their moons, the asteroids and icy comets, everything else is just dust swirling around this shining giant. If the sun were the size of a grand front door, Jupiter would be a grapefruit, and Earth no larger than a pea. This immense mass creates a gravitational well so deep that nothing in the system can escape its majestic, slow-moving waltz. Our days, our seasons, our entire reality, everything is written by this gravitational dominance. The sun is our center, our axis, the anchor around which the fabric of our existence turns. From this star flows a constant, invisible wind made of charged particles, the solar wind. It streams out of the sun's million-degree corona, traveling at hundreds of kilometers per second and washing over every planet in its path. It stretches far beyond Pluto, carving out a giant bubble in the interstellar medium known as the heliosphere. This wind paints Earth's auroras when its particles collide with our magnetic field. It is the sun's breath, its unseen touch, felt across every corner of the solar system, sweeping dust and gas all the way to its farthest boundaries. It shapes and shields our cosmic home from harsher cosmic rays drifting in from the galaxy's depths. That protective bubble, the heliosphere, is the true outer border of the solar system, a fragile cocoon in the cold interstellar sea. It's not empty, but a dynamic region filled with solar wind and stretched magnetic fields. Far beyond the planet's orbits, the solar wind slows as it meets the pressure of interstellar gas, forming a turbulent region called the termination shock, and then the heliopause itself. The Voyager spacecraft were the first human-made objects to cross that invisible edge and slip into the open space of the galaxy, where the winds blow from other stars. The heliosphere is our shared home, the sun's sphere of influence drifting through the Milky Way. And its boundary is the place where our star's breath gives way to the whisper of the galaxy. On the sun's surface, dark patches sometimes appear, sunspots, many of them larger than Earth itself. These are not flaws, but regions where immense magnetic fields rise through the surface and suppress convective heat, making the areas slightly cooler. They still reach 4,000 degrees, but against the hotter surrounding plasma, they look dark. Their number rises and falls in an 11-year cycle that shapes space weather across the solar system. Sunspots are like freckles on the face of a star, visible signs of its restless magnetic life, the pulse of its hidden heart. Sometimes these magnetic fields twist so tightly that they suddenly snap, unleashing enormous energy in a solar flare, one of the most powerful explosions in the solar system. It can hurl billions of tons of solar material into space in what's known as a coronal mass ejection. If such a burst reaches Earth, it can trigger geomagnetic storms, disrupt satellites and radio signals, and create breathtaking auroras visible even at low latitudes. A flare is a sudden, furious exhale of the star, a reminder of its dormant power, capable of touching us across 150 million kilometers of emptiness, and of how deeply our world depends on its mood. Although space is silent, scientists can convert the vibrations recorded on the sun's surface into sound, and what they hear is a deep, low, endless hum. These ripples, like waves across the surface of a pond, are caused by gigantic convective currents of plasma rising from the star's interior and falling back down again. By studying these sunquakes through helioseismology, astronomers can look inside the sun, uncovering its structure and movement the same way geologists study Earth's interior through seismic waves. That hum is the star's voice, its inner music, playing without pause for billions of years. A song of creation that we can only hear once it's translated into a form our ears can understand. Our sun is not eternal. One day, about 5 billion years from now, it will exhaust the hydrogen fuel in its core and begin transforming into a red giant. It will swell to such an enormous size that its scorching surface will engulf the orbits of Mercury, Venus, and possibly even Earth. If our planet survives, its sky will be filled entirely by the red, swollen disk of a dying star. After this phase, the sun will shed its outer layers, forming a beautiful glowing shell called a planetary nebula. At the center, only a small but incredibly dense white dwarf will remain, the cooling core of the star, roughly the size of Earth. This distant future is the natural finale of a star's life, a quiet, majestic epilogue that awaits every star like our own. It takes sunlight about 8 minutes and 20 seconds to reach Earth, traveling nearly 150 million kilometers. This means that whenever we look at the sun, we're seeing it as it was in the past. If the star were to vanish this instant, we would still see its light and feel its warmth for more than 8 minutes before eternal night and freezing darkness set in. This delay is a fundamental property of a universe limited by the speed of light. We always look into the past. Even our closest neighbor, the moon, reaches us with a 1-second delay. The entire universe is a museum of time where every object shows us only a ghost of its former self. We never truly see the present. Despite popular belief, the sun's true color is not yellow or orange. It is pure white. It emits almost equal amounts of all visible wavelengths, and their combination creates white light, easily seen in photographs taken from space. The warm yellow tint we see from Earth is caused by the scattering of blue and violet light in our atmosphere. This same effect, called Rayleigh scattering, makes our sky appear blue by filtering out short wavelengths. In space, beyond the distorting lens of the atmosphere, astronauts see the sun as dazzling white, even slightly bluish. Our perception of the star's color is an illusion shaped by light and air, a reminder that our world is only one of countless possible viewpoints. The first planet orbiting this white star is Mercury, a world of extremes, where a single day lasts longer than 2 of its years. Because of its slow rotation and its almost non-existent atmosphere, which cannot hold heat, temperatures swing from scorching 430 degrees on the sunlit side to freezing 180 degrees on the dark side. This is the greatest temperature contrast in the entire solar system, more than 600 degrees. Mercury is a planet with 2 faces, one burned down to bare rock by relentless heat, the other frozen stiff in perpetual night. Life on its surface would be an endless fight between fire and ice, a pendulum between 2 deadly extremes without a moment of rest. Mercury is also the only known planet in the solar system that continues to shrink even today. Its massive metallic core, making up nearly 85% of the planet's radius, is slowly cooling and contracting. As it shrinks, the crust wrinkles and fractures, forming huge cliffs called lobate scarps. These features, like wrinkles on an aging face, can stretch hundreds of kilometers long and several kilometers high. Over 4 billion years, this process has reduced Mercury's radius by about 7 kilometers. It is living proof that even rock and metal breathe and change on cosmic timescales, and its surface is a frozen record of its cooling heart. This small planet also has a strange rotational resonance. For every 2 orbits around the Sun, it completes exactly 3 spins on its axis. Because of this complex gravitational dance, if you stood on Mercury's surface, you would witness a surreal motion of the Sun. It would rise in the east, pause, drift backward toward the horizon, stop again, and only then begin its slow, normal path across the sky. This bizarre effect is caused by Mercury's stretched elliptical orbit and the Sun's powerful gravity. The sky of Mercury is a theater of the absurd where time itself seems to reverse, and our familiar rhythm of day and night loses all meaning. Despite the burning heat, deep craters near Mercury's poles, places that sunlight never reaches, hold vast deposits of water ice. These cold traps exist in eternal darkness, with temperatures staying near 170 degrees, allowing ice to survive for billions of years. Scientists believe this ice was delivered by comets and asteroids long ago and preserved under a thin layer of dust. It's a striking paradox. On the hottest planet in the solar system, within the realm of fire, lie hidden crystals of frozen water, silent witnesses to ancient cosmic journeys, and a reminder that even in the most hostile places, oases can exist. Mercury has virtually no atmosphere, only a fragile, fleeting envelope called an exosphere. It is made of atoms of oxygen, sodium, hydrogen, and helium, knocked off the surface by solar wind and micrometeorites, and so thin that its atoms almost never collide. Instead, they follow ballistic arcs, bouncing and falling back like tiny invisible grains. Because there is no air to scatter light, Mercury's sky is always pitch black, even at noon, and the stars shine constantly, bright and unblinking. It is a world of absolute silence and emptiness, with no wind, no clouds, no sound. Only the endless stillness of space staring down from a jet-black sky. The next planet after Mercury is Venus, wrapped in thick clouds made of droplets of sulfuric acid, which make it the hottest world in the solar system. Its surface is completely hidden from our view, but temperatures there reach 462 degrees Celsius, hot enough to melt lead, tin, and zinc. The cause is a runaway greenhouse effect. Its dense atmosphere, made of 96% carbon dioxide, lets sunlight in but traps the heat, turning the entire planet into a giant furnace where the temperature is the same day and night, at the equator and at the poles. Venus is a stark warning of how fragile climate balance can be, how a potentially Earth-like world can transform into a landscape of hell. The atmospheric pressure on Venus is 92 times higher than on Earth, the equivalent of being almost a kilometer underwater in Earth's oceans. A person, or an unprotected spacecraft, would be crushed instantly by this invisible but overwhelming weight. The Soviet Venera probes, the first to land on its surface, survived only about an hour before they were destroyed by the crushing pressure and unbearable heat. Venus is a world where the very air has the weight of stone, compressing anything that dares to touch its surface in a silent, unstoppable embrace. Venus spins in the opposite direction of most planets, including Earth, a rare and mysterious phenomenon. This retrograde rotation means the sun rises in the west and sets in the east. Its rotation is also incredibly slow. One Venusian day, from sunrise to sunrise, lasts 117 Earth days, while a year is 225 Earth days. Scientists still debate why this strange behavior exists. Some suggest a massive ancient collision. Others point to complex tidal interactions in its dense atmosphere. Venus is a planet that dances to its own slow, backward rhythm, defying the rest of the planetary choir. High in Venus's mountains, there may be an exotic kind of snow, but it isn't made of water. It is made of heavy metals. Conditions on the surface are so hot that minerals like lead and bismuth sulfides can evaporate, creating a metallic cloud. As these vapors rise into cooler altitudes, Several kilometers above the surface, they condense and fall as metallic frost on the highest peaks, such as Maxwell Montes. Radar images show these shiny deposits as highly reflective regions. It's a world where mountaintops are dusted not with snow, but with glittering metallic powder. A surreal, toxic landscape straight out of an alchemist's dream. Even though Venus's surface is hidden beneath thick clouds, radar mapping has revealed a world covered with thousands of volcanoes, far more than Earth has. Among them are huge shield volcanoes and strange structures called pancake domes and coronae. And recent data suggests that some of these volcanoes may still be active today, releasing lava and gases into the dense atmosphere. Venus has the largest number of volcanoes of any planet in the solar system, evidence of a violent geological past and perhaps an equally active present. It is not a dead world, but a sleeping force of geology, hiding beneath its toxic blanket, with a mantle that still remembers fire. And now, we approach our home, Earth, the only known world where liquid water exists in vast amounts and in all three states. Oceans cover more than 70% of our planet, forming a unique hydrosphere where life was born and thrives today. Water regulates our climate, carries heat from the equator to the poles, sculpts landscapes through erosion, and serves as the cradle for countless forms of life, from microscopic bacteria to giant blue whales. Seen from space, our world is a glowing blue marble, an oasis of life in a cold, empty universe. Liquid water is the greatest gift and greatest treasure of Earth, making it truly unique. Earth is protected by an invisible shield, a powerful magnetic field generated by the movement of molten iron and nickel in its outer core. This process, called the geodynamo, creates a vast magnetosphere that stretches tens of thousands of kilometers into space. It deflects most of the deadly solar wind and cosmic rays, preventing them from stripping away our atmosphere and destroying life on the surface. Its interaction with the solar wind produces the breathtaking auroras near the poles. Earth's magnetic field is a silent, unseen guardian, watching over the fragile world beneath it, day and night. Our only natural satellite, the Moon, plays a crucial role in stabilizing Earth's climate and making our planet far more hospitable. Its strong gravitational pull holds Earth's axial tilt steady at about 23.5 degrees, providing predictable and gentle seasons. Without the Moon, Earth's tilt would vary wildly over thousands of years, from 0 to 85 degrees, leading to catastrophic climate swings that would make complex life nearly impossible. The Moon is not just a beautiful companion in the night sky, but a gravitational anchor that grants our world stability and order. The leading theory of the Moon's formation says that around 4.5 billion years ago, the proto-Earth collided with a Mars-sized object known as Theia. The tremendous impact ejected huge amounts of molten rock from both bodies into orbit. Over time, this debris gathered under gravity and formed the Moon. This theory explains why the Moon's composition is so similar to Earth's mantle, yet it has a very small iron core. The Moon is a child of catastrophe, born from fire and chaos in the early solar system, and ever since, it has been bound to us as a memory of that violent past. Earth's atmosphere, which seems endless to us, is actually an incredibly thin and fragile layer of gas. If Earth were the size of an apple, the atmosphere would be no thicker than its skin. 99% of its mass lies within just 30 kilometers of the surface, while the planet's diameter is over 12,000 kilometers. This delicate veil shields us from harsh ultraviolet radiation, cosmic vacuum, and gives us oxygen to breathe. It creates the pressure needed for liquid water to exist. We live at the bottom of an ocean of air, and the thinness of this ocean is a constant reminder of the fragility of our existence and the uniqueness of our home. The continents on Earth's surface are not fixed. They drift slowly, moving just a few centimeters each year, roughly the rate at which human fingernails grow. This process, known as plate tectonics, constantly reshapes the face of our planet. Tectonic plates collide, lifting mountain ranges like the Himalayas, and pull apart, creating new oceans like the Atlantic. Millions of years ago, all continents were joined in a single supercontinent, Pangaea, and in the distant future, they will gather once more into a new one. Earth is a living, breathing world, its rocky skin in constant, slow, but unstoppable motion. Its geography is only a snapshot in a very long story. High in the stratosphere, between 20 and 30 kilometers above Earth, lies the ozone layer, a thin but vital shield of gas. Ozone molecules, O3, absorb 97 to 99% of the sun's harmful ultraviolet radiation, which would otherwise reach the surface, increasing skin cancer rates and harming most forms of life. This protective layer exists thanks to life itself, because the oxygen that forms ozone was created over billions of years through photosynthesis. The ozone layer is the planet's invisible umbrella, made by life to protect life, a fragile shield that we must safeguard. About 2.5 billion years ago, Earth's atmosphere contained almost no free oxygen. Then cyanobacteria appeared, microscopic organisms that learned to perform photosynthesis, releasing oxygen as a byproduct. This event, known as the Great Oxygenation Event, dramatically changed the atmosphere and caused the extinction of most anaerobic organisms. But it also opened the path for more complex, oxygen-breathing life, including us. The oxygen we breathe today is a legacy of that ancient revolution. The air around us is a memory of the first organisms that learned to turn sunlight into breath. All the water on Earth, in oceans, rivers, glaciers, and the atmosphere, is constantly moving through the global water cycle. Under the sun's warmth, water evaporates from the oceans, forming clouds. Winds carry these clouds over land, where water falls as rain or snow, feeding rivers and replenishing groundwater. The rivers carry water back to the oceans, and the cycle begins again. This endless circulation not only distributes fresh water across the planet, but also transports heat, shaping Earth's climate. It is the eternal dance of water, a rhythm that keeps our planet alive, pulsing, and dynamic. Beyond Earth's orbit, we meet Mars, the red planet, named for the iron oxide, or rust, that coats its surface and hangs in its thin atmosphere as dust. This reddish tint gives Mars a haunting glow in the night sky. Up close, however, it is a world of cold deserts, thin air, and sweeping landscapes reminiscent of Earth. Mars is a ghost planet, filled with traces of a once warmer and wetter past, when rivers flowed and lakes shimmered on its surface. Every grain of Martian sand is a silent story of lost water and a vanished era, a memory waiting to be read. On Mars stands the tallest volcano, and likely the tallest mountain, in the entire solar system, Olympus Mons. This enormous shield volcano rises 22 kilometers above the surrounding plains, nearly 3 times the height of Everest. Its base is so vast that it would cover an area the size of France, and the caldera at its summit stretches 85 kilometers across. Because of Mars's low gravity and the absence of plate tectonics, volcanoes could erupt in the same spot for billions of years, growing to such colossal sizes. Olympus Mons is a silent monument to Mars's ancient volcanic power, a frozen giant asleep beneath a thin blanket of red dust, a witness to fire long extinguished. The Martian surface is carved by a colossal canyon system known as Valles Marineris, a structure that dwarfs any canyon on Earth. It stretches for 4,000 kilometers, roughly the distance from New York to Los Angeles, and plunges up to 7 kilometers deep in places. Unlike the Grand Canyon on Earth, which was shaped by rivers, Valles Marineris likely formed when the crust stretched and cracked as the planet cooled. It is a massive scar across Mars's face, evidence of the enormous forces that once tore its surface apart. Mars has polar ice caps like Earth, but they are made not only of water ice, but also of frozen carbon dioxide, dry ice. These caps grow and shrink with the seasons. In winter, temperatures drop so low that up to a quarter of the Martian atmosphere freezes and falls to the surface as carbon dioxide snow. In summer, this snow sublimates, turning directly into gas, and returns to the atmosphere, generating powerful winds. This seasonal cycle is the planet's slow breath, an inhale and exhale that changes its climate and appearance, making it pulse with the rhythm of its tilted orbit. A wealth of data from rovers and orbiters shows that Mars once had abundant liquid water. We see dried riverbeds, deltas, ancient shorelines, and mineral deposits that could only have formed in water. There may once have been vast lakes, and perhaps even an ocean in the northern hemisphere. Where all that water went remains one of Mars's greatest mysteries. Some of it froze in the poles and underground. Some may have escaped into space after Mars lost its protective magnetic field. Mars is an archive of a lost water world, its deserts filled with the ghosts of rivers. Mars has two tiny moons, Phobos and Deimos, which look more like captured asteroids than true moons. Phobos orbits so close and so rapidly that it rises in the west and sets in the east, completing 3 orbits in a single Martian day. Its orbit is unstable, and it is slowly spiraling inward toward Mars. In a few tens of millions of years, Phobos will either crash into the planet or be torn apart by tidal forces, forming a thin ring of debris around Mars. The future of Mars may include a ring born from the death of its own moon, a sad and beautiful adornment. Between the orbits of Mars and Jupiter lies the asteroid belt, a region filled with millions of rocky and metallic bodies ranging from tiny grains of dust to objects hundreds of kilometers wide. Yet, contrary to what we often see in science fiction films, the belt is mostly empty space. Asteroids are so far apart that the average distance between them is measured in millions of kilometers. A spacecraft flying through the belt has an almost zero chance of hitting one. If you collected all the mass of the asteroid belt into a single object, it would still be far smaller than our moon. The asteroid belt is not a wall. It is a thin, scattered cloud of debris, the leftover building material from the birth of the solar system. The largest object in the belt is Ceres, so massive that its own gravity has shaped it into an almost perfect sphere. Because of this, it is classified as a dwarf planet, the only one in the asteroid belt. NASA's Dawn mission found mysterious bright spots inside Okator crater, which scientists now believe are deposits of salts left behind after subsurface water evaporated. This suggests that beneath Ceres' icy crust, there may be a subsurface ocean of salty water, making it yet another potentially habitable world. Ceres is a frozen mini-planet hidden among the rocks, an icy world that may guard the secret of liquid water. The second most massive object in the belt, Vesta, is a unique survivor, a preserved protoplanet. That means Vesta is a planetary building block that never grew large enough to become a full planet, held back by Jupiter's overwhelming gravity. At its south pole lies the enormous Rhea Silvia impact basin, so deep that it exposed the asteroid's mantle. Fragments blasted out by this impact scattered across the solar system, and some eventually fell to Earth as a special class of meteorites. By studying these meteorites, we can literally hold pieces of Vesta's interior, fragments of a world older than Earth itself, frozen halfway between embryo and planet. The asteroid belt is not the remains of a shattered planet, as once believed. Instead, it is material that never formed a planet at all because Jupiter's powerful gravitational influence constantly disturbed the orbits of these planetary seeds. Rather than merging and growing, they collided too violently and shattered into smaller pieces. The asteroid belt is a graveyard of worlds that never came to be, a fossil echo of the turbulent era of the solar system's formation, a permanent monument to Jupiter's power. Not all asteroids lie in the main belt. Some form groups called Trojans, which share an orbit with a planet, moving ahead of it and behind it. The largest population of Trojans follows Jupiter, clustered at the 2 stable Lagrange points, L4 and L5. These asteroids remain in gravitational balance between the Sun and Jupiter, held in invisible pockets of stability roughly 60 degrees before and after the planet. They are time capsules from the dawn of the solar system, untouched since its earliest days. Trojans are Jupiter's silent companions, trailing with it in its endless journey around the Sun, its loyal celestial entourage. Beyond the asteroid belt begins the realm of the gas giants, and the first and largest of them is Jupiter, the king of planets. It is so enormous that all the other planets combined could fit inside it, with room to spare. Jupiter is not solid. It has no surface in the familiar sense. It is mostly hydrogen and helium, the same elements that make up the Sun. Had Jupiter been about 80 times more massive, it could have ignited nuclear fusion in its core and become a star, a brown dwarf. Our solar system would then be a double star system. Jupiter is a failed star, the cold, dark brother of our Sun. The most famous feature of Jupiter is the Great Red Spot, a gigantic anticyclonic storm that has been raging for at least 350 years, ever since it was first observed through a telescope. The vortex is so large that 2 or even 3 Earths could fit inside it. Winds along its outer edges blow at more than 400 kilometers per hour, twisting the clouds into a massive spiral. Although the storm has been shrinking in recent decades, it remains the most powerful and longest-lived tempest in the solar system. The Great Red Spot is an eternal storm, the crimson eye of a giant staring into the darkness of space, ever-changing yet ever-present. Jupiter has the strongest magnetic field of any planet, nearly 20,000 times more powerful than Earth's, and it stretches millions of kilometers into space. If the magnetosphere were visible to the naked eye, it would appear several times larger than the full moon in our sky. This vast magnetic field traps charged particles from the Sun and from Io, Jupiter's volcanic moon, creating intense radiation belts deadly to any unshielded spacecraft or human. Jupiter's magnetic field is its invisible empire, a domain that extends far beyond the planet's visible disk, a silent authority over the space around it. Like the other gas giants, Jupiter has rings, but they are so faint and thin that they cannot be seen from Earth, even with the most powerful telescopes. They were discovered only in 1979 by Voyager 1, which photographed them from behind the planet, lit against the background of stars. Unlike Saturn's bright icy rings, Jupiter's rings are made mostly of dark dust knocked off the surfaces of its small inner moons by micrometeorite impacts. These rings are ghost-like, delicate, dim structures that fade into the blackness of space. They are a modest, dusty adornment to the giant planet, a secret necklace hidden in shadow. Deep within Jupiter, under pressures of millions of atmospheres, hydrogen takes on an exotic state known as metallic hydrogen. In this form, electrons separate from protons and hydrogen behaves like a liquid metal capable of conducting electricity. Scientists believe that the convective motions of this metallic hydrogen in Jupiter's interior act like a massive dynamo, generating the planet's extraordinary magnetic field. We cannot recreate such conditions on Earth, so Jupiter's interior remains one of the great unsolved mysteries of planetary science. Hidden within the giant lies an ocean of metallic fluid, a heart forged by unimaginable pressure, a core we may never see. Jupiter spins faster than any other planet in the solar system, completing one full rotation in less than 10 hours. This rapid spin creates a powerful centrifugal force that flattens the planet at the poles and bulges it at the equator. It is also the reason for the striped appearance of Jupiter's atmosphere. The clouds are stretched into long bands parallel to the equator, forming alternating bright zones of rising air and dark belts of sinking air. Jupiter is a spinning top in space, its rotation painting patterns across its cloudy face, a complex, ever-changing dance of storms and flowing clouds that never stops. Jupiter also acts as a cosmic vacuum. Cleaner, or more accurately, a gravitational shield for the inner planets, including Earth. Its enormous mass pulls in or deflects comets and asteroids that might otherwise enter the inner solar system and collide with our world. In 1994, astronomers watched as comet Shoemaker-Levy 9 was torn apart by Jupiter's gravity, and its fragments slammed into the giant's atmosphere, leaving dark scars as large as Earth. Jupiter is our great protector, silently absorbing blows that could be catastrophic for us, an older brother guarding the peace of the younger ones. Orbiting around Jupiter is an entire family of nearly 100 known moons, forming something like a miniature solar system. 4 of them, discovered by Galileo Galilei in 1610, stand out and are known as the Galilean moons. Their discovery marked a turning point in history, proving that not everything in the heavens revolves around Earth and striking a blow to the geocentric worldview. Io, Europa, Ganymede, and Callisto are each complex worlds of their own, with unique histories and personalities. Jupiter's entourage is a cosmos in miniature, a collection of worlds awaiting exploration. The closest of the Galilean moons, Io, is the most volcanically active body in the entire solar system. Its surface is constantly reshaped by hundreds of active volcanoes spewing sulfur and sulfur dioxide up to 500 kilometers into space. This furious activity is not driven by internal heat alone, but by a gravitational tug-of-war. Jupiter pulls from one side, while Europa and Ganymede tug from the other. These tidal forces squeeze and stretch Io's interior, heating it until the rock becomes molten. Io is a world of eternal eruption, tortured, twisted, and melted by the gravity of its giant neighbor, a world that never sleeps. Next comes Europa, a smooth, icy world with a global ocean hidden beneath kilometers of frozen crust. Scientists are almost certain this subsurface ocean exists, and that it may contain 2 to 3 times more water than all of Earth's oceans combined. Tidal forces from Jupiter keep the ocean warm and liquid, and hydrothermal vents may exist on its seafloor, similar to those that support entire ecosystems on Earth without a single ray of sunlight. Europa is one of the most promising places to search for extraterrestrial life in the solar system, an icy treasure chest holding the secret of liquid water and perhaps life itself. The largest moon in the solar system, Ganymede, also orbits Jupiter, and it is even bigger than the planet Mercury. It is the only moon known to have its own internally generated magnetic field, which creates a miniature magnetosphere inside Jupiter's enormous one. Its surface is a patchwork of dark, ancient, heavily cratered regions and brighter, younger areas marked by grooves and ridges, signs of a complex geological past, possibly even involving plate tectonics. Ganymede is not just a moon, it is a world in its own right, a planet masquerading as a satellite. The most distant of the Galilean moons, Callisto, has the oldest and most heavily cratered surface in the solar system. Its face has remained almost unchanged for 4 billion years because it has virtually no geological activity to erase the marks of impacts. Callisto is a museum of the solar system's history, its surface a chronicle of every collision it has endured throughout its long life. Each crater is a scar from an ancient strike, a frozen reminder of the chaotic past of our cosmic home, preserved perfectly for us to witness. Moving onward, we reach Saturn, the jewel of the solar system, famous for its magnificent, intricate ring system. From Earth, the rings appear smooth and delicate, but they are actually composed of billions of particles of water ice and rock, ranging from tiny grains to objects the size of houses. They orbit the planet in an incredibly thin sheet. Despite spanning 280,000 kilometers across, most parts of the rings are no more than 10 to 20 meters thick. If you looked at them edge-on, they would almost disappear. Saturn's rings are an icy lacework woven by gravity, an ethereal and breathtaking structure that reflects sunlight like a giant celestial mirror. These rings are not eternal. They are a temporary phenomenon in the lifespan of the solar system, only 100 to 200 million years old. Saturn's gravity constantly pulls ring particles inward, causing them to fall onto the planet as ring rain, a mixture of ice and chemical compounds. At this rate, the rings may vanish entirely within the next 100 million years, a blink in cosmic time. We live in a rare moment when Saturn's rings are bright and beautifully visible. We have the privilege of witnessing this wonder, a spectacle that will one day dissolve into the giant's atmosphere like a snowflake melting on a warm hand. At Saturn's North Pole rages a mysterious 6-sided storm known as the hexagon. This enormous geometric structure, each side longer than Earth's diameter, is a stable, swirling vortex with smaller hurricanes turning inside it. Scientists have recreated similar patterns in laboratory experiments, showing that such shapes can form from differences in wind speeds at different latitudes, creating a standing wave. Even so, the hexagon's perfect symmetry and decades-long persistence are astonishing. Saturn's hexagon is a reminder that within the chaos of atmospheric currents, near-perfect order can emerge, a work of natural geometry on a planetary scale. Saturn is the least dense planet in the solar system. On average, it is less dense than water. This means that if you could find an ocean large enough, Saturn would float in it like a giant striped buoy. Its low density is explained by its makeup. Like Jupiter, it is composed mostly of hydrogen and helium, with only a small rocky core deep inside. Saturn is a true gas giant, an immense ball of light, airy matter, swollen and soft like a cloud drifting through space. One of Saturn's most intriguing moons is Titan, the only moon in the solar system with a thick, hazy atmosphere. It is even denser than Earth's and made mostly of nitrogen, just like ours, but filled with methane and ethane. It is far too cold on Titan for liquid water to exist. Instead, it rains liquid methane. The rain forms rivers, lakes, and even entire seas of hydrocarbons. The Huygens probe, which landed on Titan, sent back images of a landscape strikingly similar to Earth, with river channels and pebbles made of water ice. Titan is a distorted mirror of the early Earth, a world where water has been replaced by methane, and familiar processes unfold in a profoundly alien environment. Another Saturnian moon, the small and icy Enceladus, hides a global ocean of liquid water beneath its south polar ice cap. From cracks in the icy crust, the tiger stripes, powerful geysers erupt into space, sending jets of water vapor and ice particles hundreds of kilometers high. The Cassini spacecraft flew through these plumes and detected not only water, but organic molecules, carbon dioxide, methane, and hydrogen, all ingredients necessary for life as we know it. Enceladus, like Europa, is one of the most promising places to search for life beyond Earth, a tiny frozen sphere venting secrets and possibilities into space. Among Saturn's dozens of moons are other strange worlds, like Iapetus, known as the yin-yang moon. One of its hemispheres is bright as fresh snow, while the other is dark as asphalt. This stark contrast is caused by Iapetus sweeping up dark dust on its leading hemisphere as it orbits Saturn. Another moon, Mimas, is famous for its enormous Herschel crater, which gives it an uncanny resemblance to the Death Star from Star Wars. Each of Saturn's moons is a story of its own, written in ice and rock, a separate chapter in the book of this remarkable system. Saturn's rings are not solid sheets, but are divided into thousands of smaller ringlets and gaps, forming a structure that resembles the grooves of a vinyl record. Some of these gaps are carved by the gravitational influence of small shepherd moons that orbit within or at the edges of the rings. Their gravity clears narrow paths and keeps ring particles aligned in precise orbits. The best-known shepherds are Pan and Daphnis, which create gaps in the A-ring. These small moons are the invisible gardeners of Saturn, trimming and shaping its icy garden, maintaining its delicate order and intricate beauty. Beyond Saturn, we encounter Uranus, an icy giant that rotates on its side relative to the plane of the solar system. Its axis is tilted almost 98 degrees, meaning the planet essentially rolls along its orbit. As a result, each pole faces the sun continuously for decades, creating extremely long and dramatic seasons. One day at a pole lasts 42 Earth years, followed by 42 years of darkness. Scientists believe this unusual tilt was caused by a collision with an Earth-sized object in the distant past. Uranus is a toppled world, its history permanently altered by an ancient catastrophe, a planet that still carries the scar of its violent youth. Uranus and its neighbor Neptune are classified as ice giants, unlike the gas giants Jupiter and Saturn. Although their atmospheres also contain hydrogen and helium, their interiors hold much more ice, a dense mixture of water, ammonia, and methane. Under immense pressure and temperature, these materials exist in an exotic form known as superionic water, a hot, electrically conductive state that is neither solid nor liquid nor gas. Uranus is not just a ball of gas. It is a world with depths made of strange, super-dense ionic slush, generating an odd and offset magnetic field. A world we are only beginning to understand. Like all giant planets, Uranus has a ring system, but its rings are dark and narrow, made of carbon-rich material the size of boulders. They were discovered unexpectedly in 1977 when the planet passed in front of a distant star, and astronomers noticed the star flicker several times before and after Uranus eclipsed it. These rings are some of the darkest objects in the solar system, reflecting less light than coal dust. Unlike Saturn's bright icy rings, Uranus's rings are likely young, formed from the breakup of one of its moons. They are an almost invisible necklace around the icy giant, more shadow than light, more whisper than voice. The atmosphere of Uranus is the coldest of any planet in the solar system, with temperatures in its upper layers dropping to around 224 degrees Celsius. Despite this extreme cold, and despite the fact that Uranus releases very little internal heat, its winds can still reach speeds of up to 900 kilometers per hour. Visually, Uranus appears as a smooth, featureless blue-green sphere, lacking the bright bands and dramatic storms seen on the other giant planets. Its color comes from methane in the atmosphere, which absorbs red light and reflects blue and green. Uranus is a world of deceptive calm, icy and serene on the surface, yet hiding storms and turbulence beneath its soft, uniform face. The magnetic field of Uranus is both unique and chaotic. It is not only tilted 59 degrees away from the planet's rotation axis, but its center is offset from the planet's center by about a third of its radius. As a result, Uranus's magnetosphere tumbles and changes shape with every rotation of the planet. Scientists believe this bizarre field is generated not in the core, but in a salty, electrically conductive ocean of water and ammonia that surrounds it. Uranus's magnetic field is yet another mystery of this strange, overturned world, another clue to its violent past and unusual present, another layer of its hidden story. The most distant of the planets, Neptune, was not discovered simply by looking through a telescope, but through mathematics, a triumph of celestial mechanics. Astronomers noticed that Uranus was deviating slightly from its predicted orbit and suspected that the gravity of an unseen planet was tugging on it. French mathematician Urbain Le Verrier and English astronomer John Couch Adams independently calculated where this unknown world should be. In 1846, astronomers at the Berlin Observatory pointed their telescope where Le Verrier had indicated and found Neptune less than 1 degree from the predicted position. Neptune is the planet found on the tip of a pen, a victory of human reason. Neptune is a world of the fastest winds in the solar system. They can blow at more than 2,000 kilometers per hour, several times faster than the speed of sound on Earth. The cause of such incredible winds on a cold planet so far from the sun remains a mystery, but is likely related to Neptune's internal heat source. It radiates about 2.6 times more energy than it receives from the sun. Like Jupiter, Neptune has hosted enormous dark storm systems, but these are far less long-lived than Jupiter's Great Red Spot. The atmosphere of Neptune is a kingdom of supersonic storms, a perpetual chaos at the edge of the planetary system where the air races faster than a bullet. Neptune's largest moon, Triton, is unique in that it orbits the planet in the opposite direction of Neptune's rotation, a retrograde orbit, and along a strongly tilted path. This almost certainly means Triton did not form alongside Neptune, but was captured from the Kuiper Belt. Its orbit is slowly decaying due to tidal interactions with Neptune. In a few 100 million years, Triton will come so close to the planet that Neptune's gravity will tear it apart, forming a bright new ring system that could rival Saturn's. Triton is a wanderer caught in gravitational captivity, doomed to be destroyed and transformed into an ornament for its captor. Triton's surface is one of the coldest in the solar system, with temperatures around 235 degrees Celsius, yet it is geologically active. Instead of molten rock, its cryovolcanoes erupt with a mixture of liquid nitrogen, methane, and dark dust. These dark plumes, rising up to 8 kilometers high, were photographed by Voyager 2. The energy for this activity likely comes from faint sunlight gently warming dark layers beneath the surface, building up pressure until it is released. Triton is a world of icy geysers, where extreme cold does not mean geological death. It simply changes the way a planet breathes. Deep inside the ice giants Uranus and Neptune, it is thought that it may actually rain real diamonds. Under pressures hundreds of thousands of times greater than those on Earth, and at very high temperatures, methane in their interiors can break apart into hydrogen and carbon. The carbon then compresses into diamond crystals, which, being denser than the surrounding material, slowly sink toward the core like raindrops or hailstones. These diamond rains could last for thousands of years, forming an entire layer, or even an ocean, of liquid diamond deep within. The depths of these distant worlds may hide treasures beyond anything we can imagine, born from nothing more than simple gas. Beyond Neptune's orbit begins the third and most expansive region of the solar system, the Kuiper Belt, a vast, disc-shaped ring of icy bodies left over from its formation. It stretches outward from Neptune to about 50 astronomical units from the Sun. This is home to hundreds of thousands of objects larger than 100 kilometers across and possibly trillions of comets. The Kuiper Belt is the frozen outskirts of our system, a storehouse of primordial material from which the planets once formed. By studying it, we peer into the past, into the childhood of the solar system, into its cold cradle, where time moves very slowly. The most famous resident of the Kuiper Belt is Pluto, once the 9th planet, now the queen of the dwarf planets. When the New Horizons spacecraft flew past it in 2015, it revealed a surprisingly complex and geologically active world. The most striking feature on its surface is a giant heart-shaped plain of nitrogen ice called Tomball Regio. It is almost completely free of impact craters, which means its surface is very young. Nitrogen glaciers are constantly renewing it. Pluto is not a dead ball of ice, but a dynamic world whose icy heart still beats, pumping nitrogen ices across its surface. Pluto's surface is not just flat plains of ice. It also has mountains made of water ice that rise several kilometers high. At Pluto's freezing temperatures, water ice is as hard as rock on Earth and can build mountain ranges. These ice mountains float on softer, denser nitrogen ice, like icebergs in an ocean. There is also evidence of possible cryovolcanism, eruptions of icy lava. This distant world turned out to be far more complex and active than anyone expected. A small but proud kingdom on the edge of the known world. Pluto's largest moon, Charon, is so large compared to Pluto, about half its diameter and roughly 1/8 its mass, that the pair is often described as a double dwarf planet system. They always show the same face to each other due to tidal locking, as if frozen in a never-ending face-to-face dance. The center of mass of the system lies in the space between them, so they both orbit a point in emptiness. At Charon's north pole lies a mysterious dark reddish region known as Mordor, thought to be made of complex organic molecules, tholins, that drifted from Pluto's atmosphere and settled onto Charon's cold surface. Beyond Pluto, the Kuiper Belt holds other dwarf planets, such as Eris, Makemake, and Haumea. The discovery of Eris in 2005, a body even more massive than Pluto, was one of the main reasons the International Astronomical Union redefined what a planet is and demoted Pluto. Haumea is remarkable for its elongated rugby ball shape and extremely fast rotation, completing one spin in just 4 hours, as well as for having its own ring system. These distant worlds are icy kingdoms, each with its own unique traits, waiting to be explored and guarding the secrets of the outer frontier. After flying past Pluto, New Horizons continued on to an even more distant Kuiper Belt object, Arrokoth. It is the most distant and most primitive object ever studied up close by a spacecraft. Arrokoth has the shape of 2 joined lobes, like a flattened snowman, and is what's known as a contact binary, 2 bodies that gently collided and fused in the early days of the solar system. Its surface is reddish and extremely ancient, preserved in almost unchanged condition. Arrokoth is a true time capsule, showing us what the building blocks of the planets looked like 4.5 billion years ago, the very first bricks of our cosmic home. Comets, those dirty snowballs made of ice, dust, and frozen gases, come to us from the most distant reaches of the solar system, mostly from the Kuiper Belt and the even more remote Oort cloud. They spend most of their lives in deep, frozen darkness, silent and inert. But when their elongated orbits bring them close to the sun, the ice on their surface begins to vaporize, creating a glowing envelope called a coma and a long tail that can stretch for millions of kilometers. Comets are celestial wanderers carrying messages from the icy frontier. Their sudden appearance in the sky was once seen as an omen, but today they are keys to understanding the early solar system. A comet almost always has two tails, not one, and they point in different directions. The first, brighter and straighter, is the ion or plasma tail. It forms when gas becomes ionized by the sun's ultraviolet light and is pushed directly away from the sun by the solar wind's magnetic field, glowing faintly blue. The second is the dust tail, broader, curved, and yellowish-white. It is made of tiny dust particles pushed by sunlight itself. Because dust is heavier, these particles retain more of their orbital path, creating a gentle arc behind the comet. Together, these two tails, one gas, one dust, trace two different stories in the sky, revealing how the comet interacts with our star. The European Space Agency's Rosetta mission was the first in history to place a spacecraft into orbit around a comet's core and then land a probe on its surface. The lander, Philae, touched down on Comet 67P, Churyumov-Gerasimenko, and analyzed its composition on the spot. It revealed that the water on this comet has a different isotopic ratio of deuterium to hydrogen than Earth's water, casting doubt on the idea that comets delivered most of our planet's water. Rosetta showed us that comets are not just lumps of ice, but complex worlds with cliffs, pits, dunes, and even their own dusty weather. Many scientists believe that in the early solar system, comets and asteroids bombarded the young Earth, delivering not only some of its water, but also complex organic molecules, the building blocks of life. Amino acids, the foundation of proteins, have been found in meteorites like the Murchison meteorite, and in samples collected from comets and asteroids. This suggests that the ingredients for life were not unique to Earth. They were widespread in the primordial cloud from which the planets formed. Life on Earth may have been seeded from space, carried on the icy wings of ancient comets and on rocky fragments of asteroids, like seeds scattered onto fertile soil. Beyond the Kuiper Belt, at the farthest edge of the sun's gravitational reach, lies the hypothetical Oort cloud. It is a vast spherical shell surrounding the entire solar system, filled with trillions of icy bodies thrown outward by the gravity of the young giant planets. It stretches from about 2,000 to perhaps 100,000 astronomical units from the sun, almost a full light year. The Oort cloud has never been observed directly. Its existence is inferred as the source of long-period comets. It is the final, most distant, and most diffuse part of the solar system, its frozen frontier with interstellar space. The solar system does not revolve around the sun's geometric center. Instead, every object, including the sun itself, orbits a shared center of mass called the barycenter. Because Jupiter is so massive, more than 5 times the combined mass of all other planets, this barycenter sits not within the sun, but just above its surface. That means the sun does not stand still. It makes a small looping motion, dancing around this invisible point along with the planets. This subtle dance is the key to detecting planets around other stars using the radial velocity method, because it reveals the presence of unseen companions. Most planets and asteroids orbit the sun in roughly the same plane, known as the ecliptic, defined by Earth's orbit. This flatness is inherited from the solar system's formation in a spinning disk of gas and dust that flattened as it rotated. But not all objects follow this sheet. Some, especially dwarf planets like Pluto and Eris, and long-period comets, have orbits steeply tilted to the ecliptic. The solar system is not a perfectly flat disk. It is more like a slightly warped record with a handful of off-key notes, adding complexity to its structure. In a gravitational system with two massive bodies, such as the Sun and Earth, there exist 5 points where a third, much smaller object can remain fixed relative to them. These are the Lagrange points. They are gravitational parking spots in space, where the pull of gravity and the centrifugal force balance each other. Humanity uses these points to position space telescopes like the James Webb Space Telescope at L2, where it can remain stable with minimal fuel. Lagrange points are invisible harbors of stability in the endless motion of space, quiet refuges in a gravitational storm. The space between planets is not empty. It is filled with tiny dust particles left behind by comets and asteroid collisions. This interplanetary dust scatters sunlight, creating a faint glow along the ecliptic visible after sunset or before dawn on moonless nights, the zodiacal light. When Earth passes through these dust clouds, the particles burn up in the atmosphere, producing meteors, shooting stars. Each falling star is a grain of dust from the distant past of the solar system, the final spark of its long journey, a momentary streak of light across the night sky. The Voyager 1 and Voyager 2 spacecraft, launched in 1977, are the most distant and fastest human-made objects in existence. They have already left the heliosphere and are now traveling through interstellar space, carrying golden records with information about humanity. In 1990, Voyager 1 turned its camera back toward Earth from 6 billion kilometers away and captured the famous image of our planet as a tiny pale blue dot. This photograph, named Pale Blue Dot by Carl Sagan, became a powerful symbol of our fragility and solitude in the vastness of the cosmos. All of human history has unfolded on that barely visible speck suspended in a sunbeam. The region where the supersonic solar wind suddenly slows as it crashes into the interstellar medium is called the termination shock. Beyond it lies the Helios heath, where the solar wind becomes turbulent and hot, and then the heliopause, the true boundary of the sun's protective bubble. As the Voyagers crossed these regions, they recorded abrupt changes in magnetic fields and particle flows. They became our first messengers to touch the edge of our home and report what lies beyond. It is the journey from our warm bubble into the open ocean of the galaxy, a step into the unknown. Gravity, like light, does not act instantaneously. It travels at a finite speed, the speed of light. This means that if the sun suddenly vanished, Earth would continue its orbit for a little over 8 minutes before feeling the loss of its pull and flying off into space in a straight line. Gravity is not a static force, but a ripple in the fabric of space-time, and this ripple carries information about changes in mass. We live in a universe where even the fundamental forces obey a cosmic speed limit, where nothing, not even gravity, can outrun light, ensuring an eternal delay in the flow of information. Many objects in the solar system exist in orbital resonance, where their orbital periods follow simple whole number ratios, creating a kind of gravitational harmony. For example, for every 3 orbits Neptune completes around the Sun, Pluto completes exactly 2. This 3-2 resonance stabilizes Pluto's orbit and prevents it from colliding with Neptune, even though their paths cross. Jupiter's moons, Io, Europa, and Ganymede, are locked in a 1-2-4 resonance. The solar system is full of these gravitational harmonies, forming a complex, stable cosmic symphony of celestial bodies, invisible yet all-powerful. Astronauts who have spent time on the International Space Station or walked on the moon often describe a very specific smell of space that clings to their suits and equipment after a spacewalk. They say it resembles hot metal, ozone, gunpowder, or even a seared steak. Scientists believe this scent may come from polycyclic aromatic hydrocarbons, complex organic molecules found throughout interstellar dust, as well as reactions between atomic oxygen and the materials of the spacesuit. It's the aroma of ancient matter, the same material that builds stars and planets, the scent of the void itself, a faint reminder of where we come from. Almost every atom in your body, except for the oldest hydrogen, was forged in the hearts of long-dead stars. Carbon, oxygen, nitrogen, the essential elements of life, were synthesized in stellar furnaces that lived and died billions of years before the sun was born. Elements heavier than iron, such as gold and uranium, can only be created in the colossal explosions of supernovae or the violent mergers of neutron stars. That stardust later became part of the swirling cloud that formed our sun and planets. We are, quite literally, made of stardust. walking archives of cosmic history, stardust that learned to think. Despite the dramatic sound effects in science fiction movies, space is almost completely silent. Sound is a mechanical vibration that travels through a medium such as air or water. In the near-perfect vacuum of space, there is no medium. The density of particles is simply too low. Even a massive explosion near you in space would be utterly silent. You would only see the blinding flash of light. The only sounds in space are the ones transmitted through your spacecraft or suit as vibrations, or those converted into sound by our instruments. Space is a kingdom of immense silence, a place where the universe speaks in light, not sound. From 1.5 million kilometers away, at the Lagrange point L1 where the DSCO VR observatory sits, Earth appears as a glowing, ever-changing sphere with no visible borders or divisions. From the moon, it is a bright blue-white disk whose continents and clouds slowly turn, hanging motionless in the lunar sky, never rising or setting. From Mars, Earth becomes just a bright evening or morning star, accompanied by a tiny dot, the moon. The farther we go, the clearer it becomes. Our world is one fragile, solitary ship sailing through an endless ocean of darkness, and all our divisions vanish in that cosmic scale. A year is unique to each planet, defined by how long it takes to orbit the sun. A year on Mercury lasts just 88 Earth days, while a year on Neptune lasts nearly 165 Earth years. This means Neptune, discovered in 1846, completed its very first full orbit around the sun only in 2011. If you were born on Neptune, you still wouldn't have reached your first birthday. It's a reminder that our timekeeping, days, months, years, is a purely local invention, a small human rhythm carved into the vast symphony of the cosmos. The moon is slowly drifting away from Earth at a rate of about 3.8 centimeters per year, roughly the speed at which your fingernails grow. This happens because of tidal interactions. The tidal bulges the moon raises in Earth's oceans rotate slightly ahead of the moon due to Earth's spin, pulling the moon forward and nudging it into a higher orbit. At the same time, Earth's rotation gradually slows. Billions of years ago, the moon loomed much larger in the sky, and a day on Earth may have lasted only 6 hours. This slow dance of separation will continue for billions more years, until Earth and Moon eventually lock into a final, motionless embrace. The habitable zone, or Goldilocks zone, is the region around a star where temperatures allow liquid water to exist on the surface of a rocky planet. Earth sits right in the middle of this zone for our sun. Venus is too close and too hot. Its oceans boiled away long ago. Mars lies near the outer edge, too cold, its water largely frozen. Searching for planets in the habitable zones of other stars is one of astronomy's greatest quests, because there we are most likely to find Earth-like conditions, and perhaps life. But the habitable zone is not a guarantee, as Venus and Mars show us. It is merely an invitation to look deeper. The solar system is constantly bombarded by cosmic rays, high-energy particles, mostly protons and atomic nuclei, arriving from beyond our sun. They're born in supernova explosions, near black holes, and in other extreme galactic events, traveling nearly at the speed of light. Earth's magnetosphere and atmosphere protect us from most of them. But for astronauts in open space, cosmic rays are a serious danger. Sometimes when astronauts close their eyes, they see bright flashes, not hallucinations, but cosmic rays passing directly through the retina or optic nerve, visible traces of an invisible storm. The search for extraterrestrial intelligence, the SETI program, is largely an effort to passively listen to the universe using radio telescopes, hoping to detect an artificial, technological signal. Scientists focus on narrow-band signals, something nature rarely produces. So far, not a single confirmed signal from an alien civilization has been found, despite decades of listening. The universe remains silent, or at least beyond our hearing. But the search continues, because the answer to, "Are we alone?" would redefine our understanding of ourselves and our place in the cosmos. That great silence can feel frightening, or full of hope. Our entire solar system is not standing still. It's hurtling through the Milky Way at about 828,000 kilometers per hour, completing one full orbit around the galactic center every 230 million years, a cycle known as a galactic year. The last time our solar system was in this same part of the galaxy, dinosaurs were only just beginning to walk the Earth. We are all passengers on a giant cosmic ship called the solar system, drifting endlessly through the spiral arms of our galaxy, through clouds of dust and gas, past newborn and dying stars, on a journey with no beginning and no end. Our quiet voyage through this vast but familiar home now comes to an end. We've brushed past the burning surface of Mercury and the frozen plains of Pluto, witnessed diamond rain on Neptune and volcanoes erupting on Io. The solar system is not just a collection of distant objects. It is a complex, interconnected ecosystem shaped by gravity and light. From the thermonuclear heart of the Sun to the icy wanderers of the Oort cloud, every piece plays its part in this cosmic ballet. It's a place of impossible wonders, where storms the size of Earth rage on one world, while water erupts from beneath the ice of another, hinting at the possibility of life. The dance of planets and stars will continue forever in the silent music of the spheres, and we are only a brief moment of consciousness lucky enough to witness it. If you enjoy these quiet journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here, one sleepy soul at a time. And now, just breathe. Let your eyes grow heavy, and let the soft orbits of the planets cradle your thoughts. Good night.